Okay, so in 8.7, this is our last video on factoring. We're going to look at special cases, and in particular, we're going to look at the difference of two squares, which you're familiar with. That is when we have two binomials that we're multiplying together, and there's simply one that's plus and one's minus. So they're the same except for that part. And then there's a bit of a typo here, but then we're also looking at perfect square binomials. And again, that's just where we have, either a plus b and I'm squaring it, or I'm going to have a minus b and I'm squaring that. So I really hope that you guys are familiar with these formulas down here and over here, because it's really going to help you factor and factor quickly. So moving on to the next section, so we're going to first look at the difference of squares. So notice how in the problem that they're asking me to factor, there's no middle term. There's no b value. So just like as a side note, okay, I'm just going to write a little thought bubble here. Okay, so a formal way of writing a trinomial is a squared plus b squared plus c. So a is my leading coefficient, b is just my middle coefficient, and c is a constant. So if you notice, I don't have a b, okay? So that tells me that I had the difference of squares, where I had a, oopsie, hold on a second, where I had a minus b, and then a plus b. That's how that middle part would have canceled out, right? So I know I would have used that formula a squared minus b squared, and so what I'm going to do is essentially undo that squaring. Okay, I'm going to square root the a value and square root the b value, and that's actually what will give me my answer. So, erasing all this because I need some more room. So what I'll do is I'll square root the m squared and the 64. Square root of m is just m, and the square root of 64 is 8, and so I know one is plus and one is minus, and then that's it. And then for part B, I'll do the same thing. I'll square root the 16y, which is 4y. And I know that's going to be the same. One will be plus, one will be minus, and I'll square root the 81z to make it 9z in both of them. Then for letter C, I'll square root the 9b squared and the 25. So square root of 9b to the power of 4 would be 3b squared. 3b squared. And the square root of 25 is 5. One's minus, one is plus. Now, side note, if you're kind of wondering how I got the b squared, like, what? Where did that come from? Well, I know that b squared times b squared is what will give me b to the power of 4. Okay, so that's how I'm getting that b squared part. And then for part D, I would square root b squared and the 9 to get b plus 3 and b minus 3. So when we're factoring a perfect square trinomial, so meaning that's kind of like the end result of squaring a binomial, the dead giveaway is that I'm starting with a perfect square and I'm ending with a perfect square. So those, I'm going to say in my notes, those are perfect squares. Okay, and so I'm thinking of that formula, a squared, in this case would be minus 2ab plus b squared. Now, it doesn't always work this nicely. Like sometimes I do start with a perfect square and end with a perfect square, but I'm not necessarily using this formula. Okay, so you always have to double check. So I would take the square root of 25 and the square root of 9. Well, the square root of 25x squared is just 5x. And because there's a minus in the middle, I know it's going to be a minus here. And then the square root of 9 is 3. So I always want to double check it. Okay, and so either in my head or on my paper, so I'll say let's check. And if it does in fact follow this formula, okay, it should abide by this part of the formula, the minus or the 2ab. So I should be able to do 5x times 3, which is 15x. And then if I double it, that does in fact give me 30x. So that's how I know that this is correct and I'm good to go. So looking at part B, I just want to go ahead and go back to the color blue I was using. So I'd go ahead and square root the 49, square root the 36. 49y squared is 7y. And then it's plus, because it's a plus here. And the square root of 36 is 6. So now I'm going to check it. Making sure it abides by that formula, that 2ab. That 2ab rule. So 2 times, and then I'd say 7y times 6. Well, I know that 7y times 6 is 42y. And if I double that, that would be 84y. But if you notice, that's not what I have. Therefore, this is prime where it's not going to be factorable. So then looking at C, so I see I am starting with a perfect square here and a perfect square there. So I'll square root both of them. So I get 3x and 4. I know I'm squaring it. I know there'll be subtraction in the middle, so that's what I'll put in my answer. And then I'm going to double check. Does it abide by that 2ab rule? Well, I'd be doing 2 times 3x times 4, or 2 times 12y, which would be 24y. But I don't have that. Therefore, not the correct answer, not factorable. And then finally part D, which I think I actually can zoom up on this one. Yep, sorry. I'm going to just clear that and zoom up on D. So I'm on D. Okay. So I go ahead and square root the 49x squared, square root the 4. So that's going to give me 7x plus 2, and I'm squaring it. And again, I'm getting the 7 from the 49, and the square root of 4 is 2. So let's double check it. Does it follow the 2ab rule? So let's see. 2 times 7x times 2, or 2 times 14x, which is 28x. Okay, so we're good. This is, in fact, the correct factored answer. Now, I know this section says to try on your own, but I think some of them are a little tricky. So if you're feeling confident, by all means, go for it on your own. I'll give you a hint, though. Make sure you're factoring out a GCF, or making sure that there isn't a GCF before you factor. So looking in letter A, first of all, I don't like the fact that it's not in standard form, so I'm going to rearrange that to negative 2x squared plus 512. And I notice that these aren't perfect squares. That's a problem. And so what I'm going to do is I'm going to see is there a GCF? Okay, is there a GCF? That should always be your first thought. And so there is. I notice that they're both divisible by 2. And I'm going to take out a negative 2 just so I can flip my A value and make it positive. And then 512 divided by 2 is 256. Whoops. 256. And now 256 is a perfect square. So when I square root the x, that gives me x. And then when I square root the 256, that gives me 16. And so this would be your final answer. And you want to make sure you don't forget about the negative 2 you originally took out. So same idea with letter B. 6 and 96, those aren't perfect squares, although they are both divisible by, let's see, 6. Let's just double check. 96 divided by 6 is 16. So I'm going to factor out a 6, and that leaves me with x squared minus 16. And now I've got perfect squares, and so I can break that into x minus 4 and x plus 4. So I think you guys can definitely try letter C and D on your own. So for C, okay, we start with a perfect square and end with 1. So I know it's going to be squaring a binomial. Square root of 4y squared is 2y. Square root of 9 is 3. And I would have addition in between, but I want to just double check it follows that 2ab rule. So 2 times 2y times 3. Well, that in fact would give me 2 times 6y, or 12y. So we're in the clear. And then for D, square root of 9x squared would be 3x. Now I see subtraction, so I'm going to put minus, and the square root of 4 is 2. Now the only thing is, though, let's see, does it follow that 2ab rule? So 2 times 3x times 2. So that would be 2 times 6x, or 12x, and it does not. Okay, because I have 6x. So this would be a prime, meaning it's not factorable.